you graph negative x squared plus x, as it went to the right, did it go to negative infinity or positive infinity? Negative, good. What about as it went to the left? Negative again, very good. And then for number 3, we have 2x cubed. As it went to the right, or the positive infinity, what happened to the graph? Positive infinity, good. And if you only write infinity without the positive, that's okay as well. What about when it went to the left, what did it do? Negative, good. How about negative x cubed, what happened? On the right. Negative, good. And then on the left? How about number 5 when it went to the right? Good. And to the left. Good. And then number 6, we have 1/2 x cubed plus 7. What happened when it went to the right? It was positive. And then to the left? Negative, good. All right, everybody good with that part? Just graphing it and determining if it went up or down, basically. Did anybody pick up on any patterns?
Pretty much if your A value is negative, you're like going to the right all the time.
Almost. Yeah, that probably would be true. What about the odd versus even? Like this is to the 4th, so this is an even one. What else is even? Squared, that was even. This one was even. What was true about the even?
Even share, same thing.
And that'll happen every time. Remember how we had x squared, the parabola? The ends were going in the same direction, or if it went upside down. And that's going to be true of all even degree polynomials. They're going to have the same end behavior. But look at the odds, though. What was happening with the odds? What was true every time on the odds?
But there was one that was one way and one that was the other way.
Exactly. They're always going to have opposite end values. And if you think about the parent functions, they did do opposite things, even in the parent function, no matter what the leading coefficient. So what Ethan noticed was that even coefficient did something. I'm sorry, the leading coefficient. The leading coefficient, if it was negative, what was true of my end values? They're both negative. If it's positive, they're both going to be positive. This is an even. This one's negative, so they're both negative. And then the odds, what happened if the leading coefficient was negative? Yeah, reverse that. And so if you look at that next section where it says even degree, odd degree, positive leading coefficient, and negative leading coefficient, we're going to put that all in a box. So when you look at a graph, you'll be able to tell me whether or not it's an even degree or an odd degree, and if the leading coefficient is positive or negative, just by looking at those traits of the graph. Is everybody with me so far? Good? Okay. For the even degree positive leading coefficients, the left side of the graph, is it going to go up or down? Up, very good, because it's a positive leading coefficient. The left goes up, and then the right goes up. Then what happens when that leading coefficient becomes negative? It goes down, exactly. If you think of a parabola, that makes sense. That's what happened with the quadratic. Okay. And then if you go to the odd degree, remember they did opposite things. So if the leading coefficient was positive, the left was going down, and the right was going up. So odd degree with a positive leading coefficient, so think parent function when it's an even coefficient, or a positive coefficient at the beginning. The negative reverses that. So now the left is going to go up. Exactly. So again, with a positive leading coefficient, think of the parent function. The negative reverses that. Odds always go in different directions, evens always go in the same direction. Right, so again, I can look at this graph and tell you whether or not it's an even degree or an odd degree, and I can tell you if the leading coefficient is negative or positive. Did you have a question, Kayla? So looking at this one first, is it an odd or an even degree? They're doing the same thing. The end behavior is going down on both. It's an even then. So if it's the end behaviors are the same, it will be an even degree. And then the leading coefficient, do you think it's positive or negative? Negative because it's going down. What about the next one? They're doing different things, so is it odd or even? It'd be odd again. The left is going down, the right's going up, so is it positive or negative?
Positive.
How does that feel? Is that easy? Confusing?
So they're both going in different, okay, so what makes it positive again? So like how it's going up and down?
Great question. So if it's doing different things, you have one going down, one going up. If the left is going down, so as this, the x becomes negative, the y also becomes negative. As the x becomes positive, the y becomes positive. Then it's going to be in positive. Think of that parent function. If it were doing the opposite, so if it did something like this, the opposite, that would mean that negative leading coefficient flipped it.
So then it would be positive odd.
It would be negative odd. If it was like my purple graph. Because
Oh, yeah,
now
yeah,
I got
that's what I meant. Yeah. Yeah.
You have something like that in the homework where you identify if it's odd or even, if it's positive or negative. Okay? Any questions on that? In behavior. Great. Let's go to turning points. Yay, yay.